Okay, so this is the key to section 1.5 part 2. Now, in the table below, the quadratic equations are given. So you have 4 quadratic equations here. For each quadratic equation, determine the value of the discriminant. So remember, the discriminant is b squared minus 4ac. And then from there, determine the number and type of solutions. Alright, so first of all, remember they have to be in standard form. So this one's standard form, this one's standard form, this one is, but this one's not. So we have to rewrite this one. So it'll be 3x squared minus 7x minus 2 equals 0. Alright, so for each one of those, let's determine a, b, and c. So A, let me go ahead and use another sheet of paper. So for 9x squared minus 6x plus 1 equals 0, a is 9, b is negative 6, and c is 1. So the discriminant is b squared minus 4ac. So in place of b, a, and c, I'm going to plug in these numbers. So b is negative 6, I square it, minus 4 times a, which is 9, times c, which is 1. So that's 36 minus 36, which is 0. So I get the discriminant to be 0. So you put 0 here. And what that means is that if the discriminant is 0, you're just going to get, it's going to be a real number, but it'll be one rational solution. So we check that off. Okay, now on the next one, for 3x squared minus 7x minus 2 equals 0. A is 3, b is negative 7, c is negative 2. So the discriminant is b squared minus 4ac. So b is negative 7, I squared, minus 4 times a is 3, times c, which is negative 2. So negative 7 times itself is 49, and negative times a positive times negative a positive. 12 times 2 is 24. So 49 plus 24 will give me 73. So my discriminant is 73. Now remember, if your discriminant is a positive number, okay, your solution is going to be real. But then you have to determine, and there can be two of them, so you have to determine whether it's rational or irrational. Well, this is not a perfect square, so this is not a perfect square. Right here, so this is 73 is not a perfect square, so your solutions, you're going to have two irrational. So you check this one off. Okay, the next one. Next one is 5x squared plus x minus 1 equals 0. So a is 5, b is 1, c is negative 1. So b squared minus 4ac is your discriminant. So 5 squared minus 4 times a is 1. Oops, sorry. I'm sorry, b squared, sorry. 1 squared, so b is 1. Minus 4 times a is 5, times c, which is negative 1. So 1 times itself is 1. A negative times a positive times a negative is a positive. 4 times 5 is 20. So I get 21. So, let's make sure I wrote this right. B squared minus 4ac. Alright, so 21. So, alright, so 21, so this is going to be, so again, this is not a perfect square, so it's going to be 2 irrational. Okay, the next one. Alright, next one, you have 7x squared minus 2x plus 3 equal 0. So a is 7, b is negative 2, c is 3. So it can be squared minus 4ac. So b is negative 2 squared minus 4 times a, which is 7, times c, which is 3. So that's 4. Negative 2 times itself is 4. Minus, that's 28 times 3, which is 84. And so that's negative 80. Now since the discriminant is negative, you're going to get two complex solutions. And they'll be imaginary. Alright, so you can check this one off right here. Now, let me go back and look at one of these because for some reason I thought I had one of each. So let me double check again. So 3x squared minus 7x minus 2. Let me double check that. Let's see. So b squared is negative 7, so that's 49, minus 4 times a. A is 3 times c, which is negative 2. So that's 49 plus 12 times 2 is 24. And so you get 73. Alright, so it looks like I don't see anything wrong. So I don't have any rationals here. Let me check this one again. So a is 5, b is 1, c is negative 1. So 1 squared is 1, minus 4ac, so 20, so it's 21. Alright, so it looks like these are all correct. I don't have any rational here. Alright, so let's go to the next one. So I have x squared minus 4x plus 13. We want to solve this by completing the square. So remember, to solve this by completing a square, solve the following equation. They didn't say use completing the square, so you could use quadratic formula. It's not factorable. This is not factorable. So you have to use either completing the square or the quadratic formula. Let's just go ahead and use the quadratic formula. But it's in standard form. So a is 1, b is negative 4, and c is 13. So I get x equal the opposite of b, so the opposite of negative 4 is 4, plus or minus the square root of b squared, which is negative 4 squared, minus 4 times a times c, all over 2 times a, so that's 4, plus or minus the square root of 16, negative, positive, positive is a negative, 13 times 4 is 52, all over 2, and then 52 minus 16 is going to be 36, so negative 36, all over 2. And remember, the square root of negative 36 is 6i, so 4 plus or minus 6i over 2. And then that just becomes 4 over 2 is 2, 6 over 2 is 3, so it becomes 2 plus or minus 3i. So 2 plus or minus 3i. And then this is standard form. Yeah, standard form. So standard form is 2 plus or minus 3i. Okay, so that's, oh, I'm sorry. They wanted this fraction, but they're all divisible by 2, so if you left it as 4 plus or minus 6i over 2, that's fine, because this is a fraction, and then you wrote in standard form, you reduced it, you get this. Let me go back and make sure I did this correct. So a is 1, b is negative 4, c is 13, so that's 16. 13 times 4 is 52, and then 52 minus 16 is 36. Okay, so that looks fine. Alright, so that's going to take care of this worksheet.